I'll open it up to half a mark for a few seconds. You're allowed to answer it as well, but you won't get the mark. Very close. Unfortunately, it's 5 minus the cover at each end. At 4.9, yeah. So I better actually write that up here so that anyone, you know, when you're copying the answer, yeah, length equals 5 meters minus 50 minus 50, which equals 4,900. Now, here's another one for you. Another half. See, I'm throwing away all these marks. Bar length is 4.900. Why is it 4.900 and not 4.4900? Everything seems to be in millimeters. We're drawing in millimeters when it comes to drawings. We're talking in millimeters. I've just been doing millimeter calculations. I get over here and I've suddenly put 4.900. Half a mark. This is a mechanics mark. Way, and I would be very disappointed in you guys. Mass per meter, you can't work out the total weight in kilograms without putting things into meters. Doesn't work with millimeters, alright? A lot of my students don't do that, and they end up with 4,900. They multiply it by the mass, they get a weight of like 6 million, and they don't take the noughts off, and that's the kilograms that they come up with. So if you want to do it into kilograms, which is, if you type right now into Google how much is steel, it'll tell you in kilograms the weight of steel. So we're talking about putting things into meters. So there is a mass per meter there that's on the chart up the top, and you'll see at this end for a 12 millimeter bar the mass is 0.884. Now, the gentleman there that's doing the maths so wonderfully for me, 34 times 4.9 times 0.884. And just off the top of my head, I think it's 147.27, something like that. Is that right? Yeah. Thank you. It's all right, I've got the answer over there. I'm not that clever. Won't find me on the chase. All right. Lastly, of course, we need to draw a picture. The cool thing about a straight bar is you just put the word straight. Have to be careful talking about straight bars, eh? There we go. Let's put that across there. How to get cancelled. Okay, the next bar, and by the way, there's a slight mistake in my example answer. I put each face. It's not wrong, but you should be also adding top and bottom to that. The next one is 1602. Which one is 1602? Let's have a look. Oh, that's not too bad. It's straight. It goes from the top to the bottom, but I do notice that the sketch has got it right on the construction joint. Is that wrong? Well, technically it's not wrong, because you can have the point of the reinforcing bar there, just you can't lie on it. Alright, there's enough complicating around the point there. Okay. So what we need to calculate is 2,500. So let's do that. So all of this was 1201. Let's do 1202. So it's 2,500 minus 50 equals 4,900. So that's the length of the bar. That's easy enough. Now, how many of those bars are there? So you should be able to get this one because it's going
It should be 2 for 90.
2 foot. No, it's the length of he was close before when he said 5 meters. So these bars are going to go for the whole 5 meters minus the cover. So it'll be 5 meters minus 50 minus 50, which equals 4,900 divided by 300, right? And we all know that equals 16.333, is that right? This time I'm not using the model answer.
Yeah.
Which equals how many gaps?
18.
Yes, 17 gaps. If you can tell me why,
Which
you can
one is
have
12
half mark.
Which one is 12.2?
It's more than 0.2.
Correct. It's, he just applied the 0.2 rule. It's more than 0.2. And of course that goes to 18 bars. And guess what? We can put 18 bars and 4.9 over here on our thing. So we're going a bit quicker now. So bar length is 4 point, what's going on here? 1602 is the bar, isn't it? Is that right? Yeah, 1602. And the bar length is, it's not, it's, the length is actually, there's 2,500 here.
It's 245.
Sorry, I got that wrong. It's 2,500 minus 50 minus 50 equals 2,4. Just minus 50 equals 2,450. Yeah. Sorry, my bad maths. What happened to my checker? I must have been asleep then. 2.450. And how many did we get down there? 18, didn't we? Was it actually 36 because there's 18 there and 18 there. Times 2 equals 36. So there's quite a bit of thinking to do when you're doing these. It's easy to make a mistake, isn't it? I just made one there because I just assumed there was one, but there's one each side. 36, 18 altogether on each side. 36. And that is each face, because there's one at the front and one at the back. And if we go up to the top chart there, you can see up the top, it's 1.578 is the weight of the 16mm bar. And if we multiply that by that by that, and try and beat the teacher, we get 139.18. And a straight. Now it's time to draw pictures. The next bar is shaped like that. If we push it to the very edge, it's going to be 2 meters minus cover each side. So 1.9000. And the width of that bottom anchoring slab is 400, so that'll be 300 when you take off the, so that'll be 0.300 and 0.300. Sometimes people do these in millimeters on the sketch, You don't have to draw the sketch to scale, just a stick line will do. Okay. This next one is going to be bar number 1603. And this time it's going to be top and bottom, because we're on the bottom part of the retaining wall. And the good thing is we don't have to do that calculation again, because that bar there and this one tie onto that one. It's going to be 18 all the way. So there'll be 18 of those and another 18 of those and another 18 of those. But this one here, there's two of them, that's only one of those. So the 2 times 18, you get 36 again. We don't know the length yet. We do know it's 1.578. So we've got to calculate the length. And this is what I was talking about in the lecture. To calculate the length, we need to draw this little figure out. This is 1203. So it's 300, 300, 1900. So I was talking about the steely guy that bends the steel. The whole idea, you can't bend steel at right angles. So there's going to be a curve. And when you curve something, you kind of cut the corner, so it makes it smaller in length overall. And the corner cut is given to you up the top there by the 90-degree bend allowance. See that? And for a 16mm bar, it's 36. So in other words, because that's going around the corner and around the corner, it's minus 36 and minus 36. So what it ends up being, the overall length of that is 300 plus 1900 plus 300 minus 36 minus 36, which equals, look at the time to get back, he's going to beat me this time.
2428. 2428.
2.2428. 2428. Is that right? So we said 2428. Does everybody else get that that's been staying awake? Yep, 2428. So I'll put my 2428 here. And now we're going to multiply that by that by that. And we're going to get an answer of 137.93. Lastly is the U bar. Now the U bar is going to be 300, we already talked about this bar. It's going to be pushed against the edge, so it'll be 300 because it's 400 minus 50 minus 50. Better put that over here. 1204. It's going to be 400 minus 50 minus 50, so it's going to be 300. It's the height that's the problem. So to work the height out, it's going to be, I do it this way. The height of this is 300, the next is 400, the next is 100, and the lap is given to you up the top of, now which one do we take? Where's the lady from this morning? She can tell me. Which lap do we take? The 390 or the 520? Perfect. That's half a mark for doing that. There we are. I'm being generous. Once again, you to start emailing me before midnight, yes?
Why we did not minus bending in the first part?
Because we're trying to work out, when you give the bar to the steely, he measures the overall length and then he bends it. And when he bends it, if your overall length is just 300 plus 19 plus 300, and you bend that, you're going to end up with too long. Right? But if you take off that and take off that and you give him that length, when he bends it, it'll be perfect. Alright? So it's called a bend allowance. You could draw it on AutoCAD and you'll find that it's pretty close to what the actual length. You do a P-line, do a curve, list the P-line and it'll tell you that the length has changed. Yeah. So let's do that. That's 300 plus 400 plus 100 plus a lap. So it'll be 300 plus 400 plus 100 plus a lap, but we have to also minus at the bottom this cover. So the lap is the lady there said, 520, correct, 520 plus 100 plus 400 minus 50. Yeah, 300 plus 400 plus 100 plus 520 minus 50.
170.
How much?
1270.
1270. Thank you. So that's the height. 1270. And 0.300. 1604. This one will be top and bottom and each face. There are 18 of them because we've done that calculation before. And the bar length is going to be equal to, now this is going to be equal to 1270 plus 1270 and plus the bar length for this one is going to be equal to, length is 1270 plus 1270 plus 300 and then of course minus 36 minus 36 and we get an answer there of an overall length of 2768. Yep. Two, 7, 6, 8. Yeah. Two, 7, 6, 8. 2.768. It's 1.578 is the weight. We multiply that by that by that. The answer is 78.62. Now, one thing missing, total. Now, please, when you do your assignment, don't forget to add them all up, because the whole idea of this is to get a total so we can get a price on it. Just doing that is not enough on a schedule, right? So when I allocate marks, even although you may have not got all this right, your total might be close to mine, and I may decide to give you a half a mark for your total, all right? So it's worthwhile doing that. Or it could be just a thing that bumps you from a adequate to a good, which is 75% compared with 50. The total here is 503.00. And probably put a kilogram there anyway, just to remind the client. Alright, so long as I've been on my feet for a few days, doing all your marking. There's the calcs down the end. The good news about what I'm about to show you and make available on the internet is I have got something that might also help you, is the not that one, but this one here I'll make available, the answer. Okay, so we started off by dividing that into 3 areas. We then worked out A, the first one, by taking the distance from here to here, and we got a calculation to give us 14 bars. And we applied the rule, but the rule didn't really apply. It was just still became 6. And I told you about the 2 diameter, 1 diameter, and the 50 for the cover, and the vent allowance. And we applied that to 1603 and 1604, and there's the last one that we did, and we ended up getting those answers there, which should reflect what's on the board. I know it feels a bit like I've just thrown a stick of dynamite into the water and all the fish are just sitting there with their mouths open. But really, some of that was quite simple. It's not hard maths, but what it is just getting your head around how to do it. Now the cool thing is I've got a second example here, which was done by my predecessor. Yes, I know there were people here at UTEC before the dinosaurs. We used to call him the old dinosaur and I was the young dinosaur. And he put together this little thing here. His name was Fred Curtin. And this is the answer to exercise 2. So exercise 2 is a water channel. So this is a slice cut through the water channel, but it goes for up the top there 9 meters. And the thing about this example is it introduces everything to you. So not only the stuff I've covered, but it covers every possibility in what you might come across as reinforcement. So it gives a step-by-step on how to calculate each bar. All right, and it also gives a explanation why we're doing things. Now this one here has got something that you don't have. It's got a minimum bar length, and that's very common because you ring the reinforcing guys up and you say, oh, I'm looking to reinforce my job. Have you got any 12 metre, 13 metre long bars? And they say, no, our minimum length, our maximum length is 12. So you're going to have to put a lap in it. Okay? Now that lap always is in the middle unless shown otherwise. And this you'll note that my lap's in the middle as well on the assignment. And this actually shows you how to calculate the distances when the laps are in the middle. See down the bottom there? Down a bit closer. So that's a handy little thing to refer back to for the assignment. And it also explains the diameter thing. Now, when you're drawing reinforcing with a curve, the centre line of the curve is 2.5 times the radius. The internal is 2 times the radius, and the external is 3 times the radius. Okay? So that's where I got the 2 times the radius from when we worked out how far in. But it's always the bar that's bending around. Don't make the mistake of using the bar the donut bar. A lot of people get very confused when I say the distance is 2 times the radius. And at the end of this is a very neat and tidy bar schedule. And leading on from that, and this is just about the end of me talking today, I can feel my voice going as well. On Moodle, what I've got for you there, on Moodle is an AutoCAD drawing of how we draw this. Now, that water race, looking down on it, you imagine looking down on it, so I'll show you how we draw the exact one. So let's go to wk8. There's a drawing become available here. Do not use this drawing on your assignment or copy anything from it. With the assignment, you're starting a brand new drawing. Do not use your civil drawing or anyone else's civil drawing. Brand new drawing, file, new ACAD like you did with English. This is how you draw that water race that you just saw. You'll note that when we do donuts, you do a circle. I think Ingrid got you to do that anyway, so that's cool. You'll note that sometimes the bars go in behind the other bars, and sometimes they're in front. Doesn't really matter which it is, as long as you determine one of them. You'll note that when you draw this, I want you to draw a cover line. That's on a layer called cover. And if I was to look down on this water race, this is what I would see. Now, notice there's a bar there that's bent, curves right round, the yellow one, right? How do we draw that? Very simple. We draw a donut at each end. There's the donut. At the other end, there's a donut as well. The width of those bars are dependent on, like, if I list that, it should say 12 millimeters. There are 12. And the other one, if I list it, it should say, that one there should be, so that's also 12. This one, that's 10. So the width of the P line should be, there's the other donut on the other side there. And you'll see that I've got a circle there, and it goes up to the top, and the bar rests against the cover. And down the bottom it rests against the cover. Now, like I said to this morning's class, sometimes you have to put a line through the text. It's okay to be in the region of where these dashes are, but it's not okay for it to go through any of the numbers. So it becomes a bit like a game of Tetris. You can find that out when you're doing your slab, where to put everything. that's how you represent a lap. You'll notice that that one goes to that point, and one behind laps to that point there. Of course, if it was, if they lap like that, you would have one inside the other like that. Okay? These ones start. It's easier if you, the layers that you use, the bar, see how those layers up there are 103, 1201, 1204. The layers equals the bar mark, and it's easier if you make them different colours, so that when you put things on layers, you can see that you've done it right. You've eliminated bars all the way through. Alright, so you can fiddle with the CAD drawing there and have a good look at it. You can see that I've put what I've done there. They should equal the example answers. You've got a model class exercise I've gone over, and you've got a model answer to a class exercise 2 there as well. So the past leaders are allowed to go over any of those and explain it to you again, but they're not allowed to explain the assignment in terms of, is this how you do it? Or am I right with my answer, okay? Or could you please check it? If you're looking for a place to start drawing up a plan view of the slab and start positioning some of the reinforcing on it. At the same time, have a go at doing the bar schedule. There is a bonus mark for getting the last part of the schedule right. Remember, like I said in this morning's lab, with the assignment, I'll go back to it. Assignment 3. There is a template there, and the template is looks like that. And you'll notice that there is one bar of beads in it. This one here at the bottom. I'm offering a half a mark for anyone who gets that 100% right. The straight bars are quite easy to calculate, so I'm leaving that that off the bonus list. So remember, when calculating horizontally, we take it to the centre line. When calculating vertically, we take it to the cover. And that's me done talking. If you want to make a start on your assignment, please do so. If you want to go, that's up to you. Keep the traffic. You want to ask our past student any questions?